Every great technological leap begins with a new kind of tool. Steam gave us power. Electricity gave us progress. Artificial intelligence is now giving us new ways to think. But another revolution is quietly forming. One that could change the way AI itself thinks and learns. It's called quantum computing. And when it meets generative AI, we might witness the most profound transformation in the history of computing. Let's start simple. Every computer today, from your smartphone to supercomputers, relies on bits, the familiar zeros and ones that make up digital data. Each bit is either one state or the other. But the physical world doesn't work that way. At the atomic scale, particles can exist in multiple states at once, not just here or there, but somewhere in between. Quantum computers are built to work like nature itself. Instead of bits, they use qubits, tiny particles that can be both 0 and 1 simultaneously, a property called superposition. Think of it like a coin spinning in the air. While it spins, it's both heads and tails until it lands. When qubits interact, they can also become entangled, meaning a change in one instantly affects the other, no matter how far apart they are. This lets quantum computers explore many possible solutions in parallel, rather than testing one after another, as classical machines do. However, it's important to clarify, quantum computers don't outperform classical ones for every task. Their advantage depends on how the problem is structured and which algorithm is used. For example, Grover's algorithm can search unsorted data faster than any classical method, and QAOA, the quantum approximate optimization algorithm, shows promise for complex optimization problems like scheduling or resource allocation. In 2019, Google's Sycamore quantum chip demonstrated what's called quantum supremacy, solving a task in minutes that would take classical supercomputers thousands of years. It wasn't a practical problem, but it proved the potential. As physicist Michael Nielsen wrote, quantum computers don't just compute faster, they compute differently. They use the laws of the universe as their logic gates. So how does this strange new form of computation connect with the creative power of generative AI? GenAI models like Gemini or Claude learn patterns from massive datasets. They adjust billions of parameters until the model produces human-like language, images, or music. This process takes enormous computing power, and that's where quantum might help. Quantum systems can explore many potential solutions simultaneously, which in theory could make AI training far more efficient. This idea is sometimes referred to as quantum acceleration, using quantum processors to handle the heaviest optimization steps that today's GPUs struggle with. But here's an important nuance. Quantum computers don't literally test every answer at once and pick the right one. They use quantum parallelism, a kind of massive trial in superposition, and through carefully designed algorithms, they amplify the probability of finding the correct solution. Extracting useful results from that quantum state requires precision and probabilistic measurement. That's why designing the right quantum algorithms is critical. Another exciting area is quantum data encoding, where information isn't stored as flat numbers, but as quantum states, enabling models to represent complex correlations in nature much more compactly. This concept is promising, but still challenging. Encoding and decoding data into quantum states is technically difficult, and current experiments are done on small scales. Most of today's efforts focus on hybrid models, where a small quantum circuit operates as one part of a larger classical AI system. For example, researchers at IBM and the University of Toronto are using quantum layers to perform certain pattern recognition tasks. Not faster yet, but more efficiently in how they explore data. And the relationship goes both ways. AI itself is helping quantum computing evolve, using machine learning models to stabilize qubits, predict errors, and improve hardware calibration. This creates what scientists call hybrid intelligence. AI helping quantum become reliable, and quantum helping AI become exponentially smarter. Imagine an AI system designing a new material or medicine, while a quantum computer instantly simulates molecular interactions at the atomic level. That's a real glimpse of where these two worlds could merge. But before we get there, several big challenges still stand in the way. Quantum computing is powerful, but also incredibly fragile. Each qubit can lose its delicate quantum state through vibration, heat, or even stray electromagnetic noise. That's why quantum processors are kept at temperatures near absolute zero, colder than deep space. Even then, qubits make frequent errors. To fix this, researchers use quantum error correction, combining thousands of physical qubits to form one stable logical qubit. IBM's current roadmap aims for a few thousand reliable logical qubits in the next few years, enough to demonstrate true quantum advantage, where quantum clearly outperforms classical systems in practical use cases. But we're not there yet. We also need software breakthroughs, new algorithms that can fully exploit quantum logic for AI tasks. And beyond the technical challenges lie deeper questions. If quantum AI becomes powerful enough to break encryption, who controls it? How do we regulate access to a technology that could reshape industries, science, and even global power structures? As futurist Michio Kaku reminds us, every time humanity builds a new kind of intelligence, it redefines what it means to be human. Quantum computing won't replace classical computers. It will expand what's possible. The next big leap in GenAI may not come from bigger models or more data, but from looking deeper into the fundamental laws of nature itself. Thanks for watching Smart Tech Toolbox. You can find all of the sources and references for this video listed below in the description. If you enjoy exploring the future of technology, intelligence, and creativity, subscribe and stay tuned for our next episode.